My name is Ghassemi. I'm a software engineer on the AMP core team. My focus is UI components in AMP and a lot of our extended components. Hopefully by now, you're more excited, even more excited, about contributing to AMP projects. But before we get into nitty-gritty details of the contribution process and see some code, let's talk about the principles that we all need to follow when contributing something to AMP, whether it's a bug fix or a feature or a component. What are these principles that we need to follow? You may ask, principles for what? Why can't I add whatever I want to AMP? What are these rules for? Well, AMP was born with a vision and a mission. And if we don't follow a path toward this vision, we are going to regress. We are going to disintegrate back to the status quo and reintroduce all the problems that AMP was trying to solve. And we will be back to a score one. And that's not where we want to get to. So what is AMP's vision? AMP's vision is a strong, user-first, open web forever. And this is a vision that we share with many other projects and people on the web. We are not the only one, nor we think we are the only way to get to this vision. But we do have a mission to provide one path toward this vision by creating a user-first format that helps the users and everyone else involved in the web, along with all the infrastructure and tooling that's needed for this format. And this format is AMP HTML. All right. Visions and missions are short statements, but each word is really loaded. It has a lot of weight. It carries a lot of weight with it. So in this talk, I'd like to dig deeper into the user-first part of this vision that we have. We'll dissect it into principles, rules, and guidelines to make sure that we are toward a path to the vision that AMP is going with. And you may wonder, why are we talking about this on the second talk of a new contributor day? Isn't it a little bit too early for this? Well, these principles come up in every aspect of the contribution, whether it's raising a bug, fixing a bug, or contributing a whole new complex component to AMP. There are many cases, for instance, that something in AMP looks like a bug, but it may not be. It may actually be intended. It might be intended because that's the only way to fix some of the problems that we have been facing. So even when you're thinking about raising a bug, it's worth knowing the principles that AMP was built upon. These principles also come up a lot during code reviews and design reviews. So knowing them ahead of time will help you iterate faster with the code reviewers and get your feature landed faster. All right, so what are these principles that I'm going on and on about? Well, there are multiple layers of principles. And as we go down this pyramid, at first we have the vision, which we talked about is a user-first format for the web. Then there are core tenets, and there are design principles, and there are rules and guidelines. And as you go down these layers, each layer becomes more detailed, but at the same time more flexible. You can technically change the stuff in one of the bottom layers, and as long as it rolls up to the principles of the layer above, we are still good. We have published our design principles for AMP on our website for a long time, and there's a great video of Paul explaining a lot of these principles as well on the website. But it's worth going through some of them today. One of our main principles that really capture the user-first vision that we have is the fact that we want user experience to be greater than developer experience, to be greater than ease of implementation. And that matters a lot as a contributor. When you're thinking about contributing something, user greater than developer experience, and greater than what we have to do in the code. We don't want to design for the future of the web. We want things to be fast now. We don't want to add features that browsers promise they will get into their implementation 4 years from now. Obviously, we don't want to break the web. We want to solve problems on the right layer. We want to do things that can be made fast. If something is inherently slow, if something cannot inherently be fast, that's not what we want to do. We want to prioritize user experience, but sometimes we have to compromise this, and that's OK. And that sort of goes back to this principle of not designing for a hypothetical faster future browser. Sometimes we have to make compromises, and that's fine. And we don't want to have a whitelist. Now, I like to focus on the concrete guidelines and rules that we have here that lead up to these principles. As a new contributor, I believe you will find these concrete examples and some of the solutions I'm going to present more valuable. Of course, we won't have time for everything. And as I go through some of these guidelines and rules, I will refer back to the principles that they are trying to satisfy. All right, so let's get to it. What's the first one? Content shifting not allowed without user interaction. This is a common one that I see in AMP. Whenever there is something that we want to do in AMP, it's one of the principles that we really have to think about. And it's sometimes very challenging for us to handle this. So what does this mean? First of all, why not? What's wrong with content shifting? Well, no one likes when they lose their place on a page when an ad or an image loads, and all of a sudden it pushes the paragraph they're reading a few lines down. It's just not a great experience. And in fact, it's one of the worst experiences on content pages on the web today. So AMP is really trying to avoid this problem. And this is the main reason that a lot of layouts, pretty much every layout in AMP is supposed to be static from the beginning. When a page becomes visible, from the beginning, its layout is set, and it cannot move around. So let's go through some of the examples that this sort of principle may come up and see what we can do to resolve those problems. Example 1, imagine you want to work on a new component, which is called AMP Snap Video. Now, we don't have this. We probably won't have this. But imagine this component once shows a video, and whenever the video is done playing, it wants to remove itself from the page. After all, it's a snap video. So as you can see, this immediately runs into this problem that if you remove the video, there is a chance it's going to cause content shifting for the page, because its height is going to become 0, and it may pull up the paragraph that the user is reading. So what can we do to resolve this? Well, AMP runtime has some complex logic that can figure out if a size change can actually cause content shifting. And there are a few API surfaces into this logic that can be used by components. One of these API surfaces is called attempt collapse. So essentially, the video, when it wants to remove itself, it can call this method. But it's not guaranteed. AMP runtime decides whether it can collapse the video and remove it from the page without causing content shifting. And if it couldn't, it will fail. Cases that it may not be able to accept its request is if user is looking at that video, or if the video is above where the user is reading content. So what can we do when that fails? Well, that becomes a UX problem to some extent. So that component can decide to show a placeholder, remove the actual video, show a placeholder saying this video has finished playing and you cannot play it again, or this video has been deleted, and so on. Another example that comes up often is embeds. Embeds a lot of times don't know their final height. As you know, layouts are static in AMP, so the page author has to give some sort of sizing for the component initially. But imagine you want to add a new awesome social comments component that likes to expand itself to show all the comments. So what can it do? Another API surface to the logic that I discussed is request resize. It's very similar to the attempt collapse. The component can measure, it can say, OK, I want to be 500 pixels, because that's how I can show all the comments that I have. And it can ask AMP to make that size change. But again, it may get denied. And if it gets denied, what happens is page authors can provide an overflow button that says show more or show the rest of the content. And that will be shown to the user. So in those cases, the user has to click on something, and then the comment would expand. Or the component can just take care of this all by itself. It can say, I will have an explicit UI that says show 10 more comments and so on. And as user clicks this, they will this will go through. Because we do allow any sort of content shifting, size shifting, if there is an explicit user interaction. If the user taps on something or clicks on something, that's fine. Another example related to this principle is back to static sizing. Sometimes it's really impractical to do that. So we have a component, AMP-MathML, and it was actually contributed by someone who's not a core committer to AMP project, to the project a few months ago. But how is the page author going to know what the size of this math formula going to be? It's a component that takes some math formula and renders it like this. It's really hard to figure out what the size of this is going to be, especially that this component is inline. So what can we do? Sometimes you have to compromise. Back to the principle. If we try to optimize for the user experience as much as possible. But in this case, it's completely impractical, and we make an exception. And we have made exceptions like this. So in this case, the layout for the component would be container, and it would resize itself. And that's fine. All right. The next one, and this comes up a lot as well with contributions to AMP, is the fact that most third-party scripts are not allowed to run as first-party in AMP. So when you write a component, when you contribute something to the AMP project itself, that code runs in the same context as the AMP page itself. And that's fine. But third parties are not allowed to run in that context unless they can be code reviewed to make sure they don't cause any security problems, and to make sure that they actually themselves don't get around the design principles of AMP. The big difference is the contribution code is something that gets reviewed and goes through the review process, will find issues that it may have. But unless the third party itself is not reviewed, it can cause all sorts of problems. So these come up a lot with embeds. So third-party embeds, such as Facebook embeds or Twitter and so on, a lot of them have an SDK. And their SDK essentially says, put this script on your page, put a div with this class name there, and we will go figure it out. We'll put stuff in that div for you. But that means that the script is going to run as first party in AMP. And that's something that's not allowed. So what do we do? There are actually two solutions for this. One is the service that you are trying to embed may actually have an iframe-based embed API that can be used. And both of these solutions are all about sandboxing the third-party JavaScript. So we want to sandbox it in an iframe so it cannot mess with the parent page. It cannot cause security issues. First option, they may already have something like that. So YouTube is a good example of that, and Instagram is another good example of that, where you just, they give you a URL, and then you put it on an iframe, and it's all good. Some services may not have that, and that's not a problem, because AMP can give you a third-party iframe automatically. It's essentially a randomly generated subdomain on the ampproject.org, which is a cross-frame iframe. And your code, your extension code, will run as first party. And you can write some other code that runs inside that iframe and loads the SDK and does whatever it needs to do. And these two can talk via post messages. So you can use this mechanism as well. And AMP Twitter, AMP Facebook, AMP MathML actually use this approach. All right, the third one, and this is fairly important as well, is fetching external resources. And expensive operations, doing expensive operations, must be done lazily. Now, this is one of the core parts of AMP runtime, is resource managing. And you will hear more about this tomorrow. There is a talk that deep dives into how the resource manager in AMP works. But essentially, we want to do work only when it's needed. And you can see the benefits of that. If there is a component that's few viewports down the page and the user may never even get to it, what's the point of going and fetching all this data and running all this JavaScript? There is no point. So AMP runtime decides when it's a good time to fetch and do expensive work for a component. And it leads to increased performance and decreased waste. So examples of this, lots of embeds. Anything that essentially needs an iframe can be both expensive and is fetching external resources. So those need to be considered. But some components may not be fetching external resources. They may just be doing a lot of expensive work. So AMP VR viewer, for example, we don't have this component. But if we were to build one and it had to run a lot of codes, ideally it does that lazily. The solution for this, you will see some code today in one of the talks and a deep dive tomorrow. But essentially, every component in AMP has a few lifecycle methods that the runtime decides when to call them. For now, suffice to say, there is a build and there is a layout phase. And layout phase is when AMP decides when it's time to do some heavy work. So it's important for your component to do all of its heaviest stuff inside the layout phase. Another thing you can do is adjusting this resource loading mechanism. So runtime gives you some flexibility on deciding when a component should enter the layout phase. And that's through a number that you can specify for your component. So by default, most components get laid out when there are 3 viewports away from where the user is. But for some heavy components, that might be too much. You may want to change that to a lower number so we don't want to start doing expensive work too early. For AMP YouTube, for instance, we are setting that number to less than 1 because AMP YouTube is fairly heavy because of the YouTube scripts. Any external communication during pre-rendering is disallowed. And I've seen a lot of cases that violate this as well. This is fairly important for privacy. So as you all know, AMP can be pre-rendered. That's one of the reasons it's instant, because it's pre-rendered, and as soon as it comes to the view, the user can view the page. But we don't want to leak any information about the user in the pre-rendering phase. This is very important for privacy, because the user has not really shown their intention to view the page yet. So during pre-rendering, we don't want to expose any of the cookies. We don't even want to expose the IP address of the user. So that means absolutely no external communications during pre-rendering. This one is somewhat simple to satisfy as long as you stick to the previous principle and do all the external communications during the layout phase. Automatically, this will satisfy because the AMP runtime never goes to the layout phase during pre-rendering. Extensions should not block rendering of the page. Now, this one is also somewhat obvious because AMP wants to be instant. So the main page, the main content of the page needs to be rendered immediately. And as you have noticed, all the scripts in AMP are async anyway. So extension JavaScript are async, and therefore they should behave in an async way. This actually does not impact a lot of components because you're usually a UI component which is given a box, and the box is getting some loading by default, and when your extension loads, it's going to fill that box with some UI. So automatically, this works fine for most cases. But it matters for a few cases around personalization and dynamic content. For example, showing different content when the user is logged in versus when the user is not logged in. How do we handle these cases? It's actually a hard problem. It's one of the most active areas of discussion in AMP. So if you have ideas, it's a good one to engage in. But a lot of times, it comes down to compromising. Sometimes you have to compromise a little bit of content shifting to let the script do some stuff after it loaded. And sometimes you may need to block rendering of the page. So most cases, it doesn't matter. But it's an important one to consider. And it's a hard one as well. Slide recalculations should be minimized. Now, this one is about frames per second performance. In AMP, we like everything to be 60 frames per second. And what happens if the code for an extension does lots of measurements and mutations of the DOM randomly? Every measurement is going to relay out the page and bring down the performance. So that's not great. The solution to this, fairly straightforward. AMP provides ways of batching measurements and mutations through an API. So you would consider doing all of the reads of the DOM through this API and all the mutations in the second API. This comes up a lot during code reviews. Binary size matters. The size of the JavaScript file for the extension matters because not everyone is on fast networks. It's lots of JavaScript to be downloaded. The parse time of the JavaScript itself can affect performance. So it matters to bring this down as much as possible. There are multiple solutions to this. So when you're writing an extension, AMP itself has lots of utilities that you can use for DOM manipulation and so on. In short, you don't need jQuery. But the third party behind the component also matters. So if you are embedding a third-party service, that JavaScript that gets loaded inside that iframe, if you have control over it, it would be great to optimize that and follow the best practices to make sure the thing itself is also optimized in terms of size. Only GPU-friendly transitions are allowed in AMP. And this is back to the same principle. We want fast experiences for the user, and we want to do things that are 60 frames per second. And we also want to do only things that can be made fast. So some transitions are inherently cannot be moved to the GPU layer and cannot be fast. So we don't want to use those. This follows best practices on the web. Just use opacity and transform in CSS if your component needs to do something like that. And avoid transitioning top, left, height, width, and so on. If you are building a component that allows the user to provide configuration for the transition, make sure you block the properties that are not GPU friendly. And AMP animation does this. It does not allow anything that's bad for performance and only allows transitions for the ones I mentioned. And last but not least, testing. This also comes up a lot in PR reviews. And it's back to don't break the web. As you saw, AMP is used a lot, and it is released weekly. So it's important to know about our supported browsers. We support the latest 2 versions of every modern browser. But we also support older browsers to some extent, meaning it may not be perfect, but it will work. And that's for IE 11, iOS 8, and older Android systems, and Chrome 41, which a lot of crawlers, search engine crawlers use to render pages. And testing cross-browser, testing with accessibility, assistant technologies such as TalkBack, VoiceOver, and overall having integration and functional tests for the components is also important for the principle of not breaking the web. Thank you all.